Section 3.6, Mathematical Models, Building Functions. Example 1. Let p equal xy be a point on the graph of y equals x squared minus 8. Part A. Express the distance d from p to the point 0, negative 1 as a function of x. It's useful in these questions to, if possible, draw a picture of what's going on here. So let's draw a picture. Recall from previous classes that y equals x squared minus 8, that's going to be a parabola with a vertex down at 0, negative 8. So let's make a rough sketch of this. So I've got a parabola with a vertex down at 0, negative 8. And remember, it's going to open up because the coefficient of the x squared is positive. So this is 0, negative 8. So we're looking for the distance between the point 0, negative 1, which would be about right here, and some point P on that graph. So that P could be any point on this graph. So this is just a generic point P. So as we move along this graph, the distance is going to change. So as we go farther and farther up the parabola, that distance would increase. So we're looking for this distance d as a function of x. Recall that as a function of x means the only variables in the equation besides d are x. So let's first recall the distance formula for the distance between 2 points. So remember, that's the square root of x2 minus x1 squared plus y2 minus y1 squared. So here we've got to change all these variables to x2, x1, y2, y1. We've got to get those all to x's in order to have this a function of x. So we want it to eventually be d of x. So the 2 points that we're going to substitute in here are x1, y1, or x2, y2 are going to be the point 0, 1. That's fixed. But then this xy is going to change, so we'll just put a generic xy in there. So substituting into our equation here, we'll have x minus 0 squared plus y minus negative 1 squared. So my minus minus will just become a plus. So this is going to be the square root of x minus 0 is just x, so x squared plus y plus 1 squared. Now, this still is not a function of x because we've got x and y in there. So we've got to somehow substitute in for this y. Well, we know that anywhere we go on this graph, the y value is going to equal x squared minus 8. So we're going to substitute x squared minus 8 in for this y. So we'll have the square root of x squared plus, now substitute in x squared minus 8. Instead of that y. So now I just need to simplify. So we got x squared. Now x squared minus 8 plus 1 is just x squared minus 7. And now x squared minus 7 squared, that's going to give us, so remember the shortcut for squaring a binomial, square the first term, so x squared squared would give us x to the 4th. Multiply x squared times negative 7, that's negative 7x squared, and double it, so that'll give us negative 14x squared. And then we square our last term, negative 7 squared would give us 49. You could also write that out, x squared minus 7 times x squared minus 7, and distribute. Most of us would use FOIL to distribute, and that would get you to the x to the 4th minus 14x squared plus 49. So now if I collect my like terms, this is going to give us x to the 4th minus 13x squared plus 49. So my function, d of x, equals square root of x to the fourth minus 13x squared plus 49. So now, part B, I'm going to use this function to evaluate and substitute in different x values. So part B, what is d if x equals 0? So I'm just going to substitute a 0 in for x, so I want to find d of 0. So I'm going to take 0 to the fourth minus 13 times 0 squared plus 49. So if I simplify here, 0 to the fourth is 0, 0 squared is 0. So this is just going to give us the square root of 49, which is 7. So if we look up at our graph, that makes sense because here, if my x value is 0 on this graph, that would have me down here at 0, negative 8, and the distance between 0, negative 1 and 0, negative 8 is definitely 7. Part C, what is d if x equals negative 1? So I'll substitute in a negative 1 for x. So I want the square root of negative 1 to the fourth minus 13 times negative 1 squared plus 49. So simplifying here, negative 1 to the fourth is 1. Negative 1 squared is 1, so times negative 13, that's negative 13, plus 49. So 1 minus 13 is negative 12. Negative 12 plus 49 would give me 37. So the exact value of the distance would be the square root of 37. If we enter that into the calculator, that's going to give us approximately 6.08. So just pay attention in the problem in my math lab, whether it wants the exact answer, the square root of 37, or an approximated answer.